Hello, everybody. I apologize for the delay. The lectern computer, which they replaced on last weekend, has stopped working again. So I'm having to try an alternative way, and hopefully someone will come and fix the lectern computer and I can go back to teaching normally. But for the moment, I'm going to have to teach like this. My apologies. So, but we can get started nonetheless. Okay, so just some announcements before we get started. Next week is the practice for the computer exam. So the computer exam is in a fortnight's time during ordinary class time. Next week, we'll have a practice session where we can discuss any issues you may be having. We can go through some examples and so on and so forth. So that will be this time slot next week. The week after that, so a fortnight from today, will be the computer exam itself, and that will be held during class time. You'll get some, I'm not sure if you've been given the full instructions yet on it. If not, you will receive them soon as to how to access it. There's some software you'll need to install on your computer well ahead of time so that you're ready to go for the exam. So please read carefully your emails over the next 2 weeks to make sure you're on top of anything. I'll share everything that I get with you, but I don't necessarily get the same emails that you guys get. Yeah. So in order to prepare for the computer exam, then what you need to be doing is practicing spreadsheet modeling, practicing the linear programming, practicing the aggregate planning model that we looked at last week, having a look at the computer practice questions in the practice question set, having a look at the practice computer exam, which is up on Canvas. And next week, I'll post the solution spreadsheets for that practice exam as well. Yeah. If you've got any questions, please email me or come and see me during my regular consultation time. I run it on Zoom on a Monday afternoon. Otherwise, if that time's not convenient for you, drop me an email and we'll arrange a time which is convenient for everybody. Okay. So. Okay, so tonight we're going to be talking about data presentation and data description. So we're going to be talking about data presentation and data description. And we'll have a chance to have a bit of an exercise looking at some of these concepts, and we'll talk more about just what it means to communicate well using data. The idea behind this is that there's some techniques which we all need to know for managing data. So things like descriptive statistics, those sorts of basic statistics are important to be able to do yourself or to be able to interpret the results that other people provide you with. It'll become more relevant for this course over the next few weeks when we look at forecasting, particularly demand forecasting, and move into looking at simulation modeling, which deals with probabilities. So that's why we're starting this now. I think it's also important to be able to make good decisions based on quantitative evidence. We know that's what employees want to see from graduates, people who can do some basic data analysis and can communicate those results well. As you go through your studies with us, you'll learn some more advanced techniques in data description and presentation. And yeah, you'll have some time to go through those. But for the time being, we're going to keep it nice and simple. Don't worry if this is simpler sorts of statistics than you're used to. We will get on to some more complicated applications later, but keep in mind that what I'm trying to encourage you to get into the mindset of is using data as evidence, using data to support arguments, and communicating with data to influence others. Okay. So we'll go back over tonight the steps to modeling data, descriptive statistics theory, and look at measures of both central tendency and dispersion. We'll also talk about effective presentation, and then we'll go through an activity where in teams, you'll do some simple data analysis in order to make a recommendation. So we've spoken about the steps to modeling data before. I've emphasized the importance of understanding the problem, understanding the data, and we've spoken about cleaning the data. We were looking at data set number 2 for that, cleaning the data a few weeks ago, and we'll go back to looking at data set number 2 after the computer exam. Remember, by understanding the problem, well, you ensure you collect the right data for one thing. You ensure that you do the correct analysis for another. You also need to understand the data to know what it's capable of, if there's any issues in the data set. Cleaning the data, you can go back and refresh your memory on that. There's a lot of information in the online course about that. Cleaning data is about making sure that the data is fit for purpose, that you've identified if there's any mistakes in there and you've thought about what to do to correct those mistakes, whether it's to leave some of the data out, whether to fix it yourself, whether to go back to the primary sources, something along those lines. The next step is to analyze the data according to what the problem requires. Tonight, we're going to be looking at descriptive statistics. In a few weeks' time, we're going to be looking at relationships in a data set, which involves correlation, simple regression, multiple regression. A few weeks after that, we'll be looking at demand forecasting, and we'll look at auto-regressive models, time series analysis. Up to now, we've done some work with optimization models, spreadsheet models, and so forth. We always need to check that our model is doing what it is that we want it to do. That depends on the type of analysis that you're doing. We're going to be looking at hypothesis testing. We're going to be looking at the common sense test and diagnostics. We've done quite a bit of work on that, some things like sensitivity analysis as well. Checking your model, well, it's making sure the model is doing what you think it should do. Do the results make sense with what you're expecting? If they don't make sense with what you're expecting, if they're a surprise, is that because you've done something wrong? Or is it just that you found something surprising in the data that you weren't expecting? That can be hard, but what it means is going back and checking usually. And we've seen examples where we've made some simple mistakes. We've had to go all the way back and check every single formula in the model. I've spoken about some of the formula evaluating techniques that we have, etc. Yeah, so that's about checking your model. Does it make sense? With linear programming, if you remember, we looked at does the result make sense in terms of were the constraints satisfied? Were we producing too much? Had we accidentally maximized cost or minimized production? And, that was checking the model. We can also look at interpretation and presentation. We've done some work with charts. We've looked at how to present a spreadsheet neatly. With linear programming, we were looking at interpretation in terms of, well, once again, the sensitivity report, what that tells us, what the main model tells us. This, we were doing what-if analysis as well. Today, we're going to be looking at some of the steps for step 4 to 6, using some simple data analysis, descriptive statistics, charting, tables. So, any questions about what we've covered so far? Okay, well, let's then go on and have a look at descriptive statistics theory. We use descriptive statistics because raw data is usually too complicated for us to understand. For instance, cricket. I think the game of cricket is enjoyable to watch, but it's very complicated. Descriptive statistics, though, allows us to use data to characterize or summarize a situation in a meaningful manner, such as, for instance, a cricket scoreboard. That's a summary of the match. Does that cricket scoreboard make sense? Does everybody understand what it's saying there? Make sense? Not really? Okay, we've got a couple of people saying yes, that they understand it. Obviously, they understand cricket. So the point making here is, unless you understand the underlying situation, like the game of cricket, then descriptive statistics aren't really going to help you much. But you can think of descriptive statistics like a scoreboard of any sport that you're interested in. This particular one, well, a colleague of mine was presenting this for me a few years ago. He's English, and England was beating Australia, so that's why he chose to present this one. He changed the picture on me and changed the example. I've been using it ever since in his honor. So, in the 2018 World Cup, France beat Croatia 4-2. Is that an accurate description of the game? People who remember 2018, is that accurate? Yeah, got some nods here. What about online? Is that an accurate description of the game? Feel free to Google if you want to look it up. Yes, so just a second, everybody. Someone's here to help fix the ICT problem. So I'm having to run everything off my laptop. The lectern computer is not working. It was replaced on Saturday. Oh, yeah. But as of today, it is nothing's.
Right, okay.
So absolutely nothing's working.
We just, do you mind if I just reboot the PC?
Yeah, sure, yeah.
It's really strange. Well, I'll continue to monitor this one. I'm actually based in this building as well, so I can come back tomorrow and have a check. If it's still playing up, I'll flip it over again.
Thanks. Sorry, they're just trying to fix that, so that's going to take a moment. But while that's happening, can I keep using the?
Yeah.
This?
Yeah.
Yeah. Okay. Great. Yeah. So sorry, that's just someone here for ICT. So France did beat Croatia 4-2, right? Yeah. So it's accurate. Is it a complete description of the game? We've got a couple of people saying no. Why is it not complete? Yep, penalties, red cards. Yeah, there's details omitted, right? Was it the case that France scored 4 goals in the first 5 minutes, and then Croatia managed to claw back 2, but were never in the game after the first 5 minutes? Or is it that it was 2-0 until the 92nd minute, at which point France managed to put 2 away in the last minute? You can't tell, can you, just from looking at this? So the actual score is a complete description, is an accurate description. That's what the record books are going to show. In 100 years' time, someone will go back and look and say France beat Croatia 4-2. But unless you watch the whole match, you wouldn't really know much more than just, well, France won. Was it an exciting match? It's 6 goals scored, sounds exciting. But what happened? How well did the teams play? What was the weather like? All of that could be relevant information. So the point that's here, I hope you can see, is that a description should be accurate, but it can never be complete unless you're actually there, unless you can understand all the data, then it can't be complete. But the thing is, we can't understand everything. We can't understand everything. We can't understand everything because we can't play back the whole 90 minutes of the match in our heads instantly. Humans just can't do that. And even if you could, the TV recording isn't the full detail. There's some angles were missed. You don't know what the players were thinking. You don't know what the coaches were thinking. So it's never going to be complete. Okay. So I'm just going to have to, now the computer's working again, so I'm going to need to log in over on this computer. While I'm doing that, have a read through this terminology and think about population versus sample. Once you've read through the difference between the population and the sample, think about sales figures for your company. Think about what the population of sales figures might be and what a sample of sales figures might represent. And while you're thinking about that, I'll set the computer back up again. Okay, so hopefully that should now be working. Can you hear me out there online? Great, thank you. Yeah, we might also have a workaround for students to be able to hear. We're just going to do a test. Can you say something? Could you hear that? The student speaking then?
No.
No, okay.
Yes.
Okay, so try. Did that come through?
No.
No, okay. I'll keep playing around with it, but we've at least had a try. Anyway, so what we're going to, well, now we've done that, can you tell me with the sales forecast that I was talking about earlier, what do you think is the population for the sales of an organization? The sales figures of an organization, what would be the population? Could be, yep, so the number of customers was the first suggestion. The population as a whole, yeah? Yes, because the population at large could be considered potential customers. Any other thoughts? Yeah, customers, your inventory, your monthly average sales. Yes, all of those are relevant answers. To me, when we're thinking about sales figures, you're wanting to think about what it is that you're interested to know about. If you're interested to know what it is that you're currently doing, then you would be measuring your current sales. If it's looking about potential, that might be your people who purchased something from you in the past, people who may be thinking about purchasing from you, people who may be able to be convinced to become your customers. So in the population is everything of interest. So you have to define what is your area of interest in this. It could be the number of items you've sold since you opened the store, all the way through to the number you're going to sell into the future. What might you want to sample out of that? Any thoughts? Yeah, what sort of a sample might you want to take from that data? Remember, a sample is a subset of the population. Yeah, so you might want to focus in on the ones that are most likely to purchase a product. Direct sales for one part of the sales. The actual ones, yeah. Yep, so what you actually sold, what you sold last month. Yeah. So the reason why we use samples rather than the full population is sometimes it's hard to access the full population. As an example, when you're producing cars, you want to know that your car is safe. There's the Euro cap, I think that's how you say it, accident test, where you literally crash a vehicle and see how it performs. And your car comes out with a score, and you advertise your car accordingly. And see, people who value their safety will purchase the car with the highest score that they can afford. The population there is every car that we're going to sell, every car that's going to roll off our production line, because our customers want to know that every single car is safe. We can't crash every single car though, because you have nothing to sell. So you crash one car and you test how it performs. So there the sample is that one car that's crashed, and that stands in for the whole population. That's a very extreme case where the sample is the size of 1, because it's impossible to get a bigger sample without spending a lot of money. And you would never measure the population, because then you'd have no cars to sell. It's a destructive test. A simpler example around the sales would be, you want to know why it is that young people purchase your product. Why? Because you want to attract more young people to buy your product. You're positioning your product in the market as something that's youthful and appeals to young people and the young at heart. So you want to know what young people value in your product, why they purchase your product and why they don't. So what you do, instead of asking every single person who's purchased your product and every single person who hasn't purchased your product under the age of 30, what they think about your product. No, you don't do that. Instead, you collect a sample of data. You might run a focus group where you bring in 5 young people who purchase your product and 5 young people who don't purchase your product, and get them to talk about your product. It's expensive to do something like that. So we do a sample survey rather than getting information about literally everybody. The only people who collect information about literally everybody are the government through censuses, and the likes of the big tech companies, the Facebooks and the Googles. For everybody else, we collect a sample because it's either cheaper or it's not physically possible to explore the whole population. The idea is that the sample stands in for the population. That makes sense? The sample stands in for the population. You learn about the sample of 10 young people, and you then draw conclusions about everybody else. Because we don't care so much about why those 10 young people buy or don't buy our product. We care about the 10,000 young people who might want to buy our product. That makes sense? Yeah. So that's the difference in practice between a sample and a population. So, yeah. When we collect the data, we'll usually say it's one of 3 types of data. We'll typically talk about categorical data or nominal data. That's the first type of data. You hear different names for it: categorical, nominal, things like that. Categorical data is data that can be put into a bucket, basically, but there's no particular order to those buckets. So if I asked people how they traveled to work today, that's a category. You'd say bus, train, car, walk. What brand of smartphone do you own? That's categorical data. The pens in our warehouse, those are either blue, red, black, or green. Those are categories. So your SKU is a category. Really, with categorical data, all you can do is count it and come up with percentages or counts. And we will talk about the mode, which is the most commonly observed one. So if I'm looking around the room now and I can see that there's 2 PCs here, including mine, 2 Macs, and I'm not sure what's your one, a PC. Yeah, so we've got 2 PCs, 2 Macs, and one I couldn't identify, which would be, give me an NA or something. But now I've identified it, I cleaned the data and found out we've got 3 PCs and 2 Macs, which means the mode is PC, the most commonly used one. So that's categorical data. The next type of data we have is ranked data. It's also called ordinal data. That's still categories, but there's a definite order to those categories. So if we look at the team's position in a football league, so who's on top, who's at the bottom, that's an order. First, second, third, fourth, fifth. If we ask your customers to rank your company against your peers, so I'd say, who makes the best pens? That's ordinal data. List out the pen manufacturers from best to worst. Or we ask people to rate our customer service. Excellent, good, fair, poor. That's an order because excellent is better than good is better than fair is better than poor. When you collect ordinal data, you can get information about the frequencies and the modes, just like before, but also things like the median, what the middle score is, or the percentile. So something like 10% of our customers think we're excellent. That's ordinal data. The final type of data is quantitative or numerical data. That's a number where the number itself makes sense. Quantitative numbers. So how many pens did we sell last year? That's quantitative information because 1,000 pens compared to 999 pens, well, it's 1 more pen. It actually makes sense, the numbers. How many smartphones did we sell last year? How many students are using a PC? How many students are using a Mac? How many students are using a smartphone or something to access class? Those are quantitative, also known as numerical data. There are some other kinds, more exotic, like you might hear the term ratio data being used. but they're all just subtypes of quantitative data and they're not really relevant for this unit of study. Why do I tell you this? Why do we care? Well, the reason we care is that the sort of analysis we can do depends on the type of data we collect. If you collect fewer descriptive statistics, then you can't do as much analysis. So if you've got categorical data, you can't do as much in the way of descriptive statistics analysis, so you don't get as rich information. If you collect quantitative data, then you can do a lot more descriptive statistics. You can get richer insights. I speak from experience here, so I think I might have mentioned it. Survey I did where I collected the wrong type of data, ended up not being able to do the analysis we wanted to do. We were able to save that in that case, but it could have been a big issue. We also sometimes draw a distinction between continuous and discrete data. Continuous data means that any value within a range is possible. So the temperature outside could be 21 degrees, or it could be 21.1495980298354 degrees. Temperature is continuous because any number is possible. Discrete means only particular values are possible. So if you count the number of pallets in the warehouse, that should be an integer. I mean, you're not counting half the pallet, which is, you know, half a broken pallet in there. You're counting your 1 pallet, 2 pallets, 3, 4, 5. So that's discrete data. That has some impact on some of the kinds of analysis we can do. In practice, though, we always just assume the data is actually continuous, even if it's not. It's something which upsets some mathematicians, but in practice, it doesn't matter. So let's see what you think now. I'm going to open up a poll. And yeah, have a look at the data on the screen. This is what we call a Likert scale. You'll probably have seen them as a scale response. You see them all the time. It can be something like a smiley face, a plain face, and a grumpy face, and you press the button to say what you think about the customer service. What I want you to think about is this kind of data categorical, ordinal, or numerical data? So if you're asking your customers to rank sales, sorry, rank your customer service. Sorry, let me start again. If you're asking your customers to rate your customer service, you'll probably present them a Likert scale to do that. If you like, yeah, that would be something else. Or it's not a scientific poll, so you could do what you want. Yep. So yeah, feel free to just, if you haven't already answered, just have a guess. See what you think it is. What type of data are Likert scales? Are they categorical, where you can put it into a bucket, for instance, or a bucket which says good customer service, bad customer service, and so on? Is it ordinal, where there's a still categories, but the categories are in an order of some kind? Or is it numerical data where the numbers have meaning? So still 10 people who haven't answered. So please give it a guess. It's up to you to say what you, yeah. Sure.
I think it's, I strongly think it's ordinal, but I also feel like it's sort of unique.
Okay, that's a fair point. Yeah, but then there would be something else, I think, probably the best. Yeah. So just in the class, we're having a discussion about the poll itself. So this poll gives you 4 options: categorical, ordinal, numerical, and something else. The question we're having is, saying, what if it's 2 of those? What if it's all of them? And you'll notice this poll doesn't give you that option. You have to pick one or the other. A poll which asks you to pick one or the other is assuming that it's mutually exclusive. I'll put that in the chat box. Mutually exclusive means either or. It can't be both. So that pen can't be red and blue. It has to be either red or blue. We're talking about simple pens. Yeah, so if you're not sure, if it doesn't quite fit with what you're understanding, then you've got to pick one. So you'd pick the best one. The other concept is exhaustive. Exhaustive means it covers all the options. Given there's 3 types of data, and I've also given you a something else option, then this is exhaustive. It covers every eventuality, but the options aren't necessarily exclusive, which could mean it's not a good poll. I'm going to end the poll now. I see the most, 42% of you voted for ordinal. And then we're evenly split between categorical and numerical, with a couple of people saying something else. The mode, the most commonly chosen option, is ordinal. Now, that was a little bit of a trick question, because a Likert scale is a little bit complicated. So, are there categories in a Likert scale? Yeah, so it's definitely categorical data because there's categories there. But do those categories have some sort of structure to them? Yeah, if it's from best to worst, you can arrange them in a line and that line would make sense. Which means it's ordinal data. So Likert scales are actually ordinal data. The reason being is it's hard to say what the difference is between excellent customer service and good customer service. You can recognize it, but if you compare good customer service to excellent customer service, is that as far apart as good customer service and fair customer service? Is the distance between fair and good the same as the distance between good and excellent? Hopefully it should be. Here it is, but we don't necessarily know that. We're relying on the person to make that interpretation for themselves. So it's not necessarily the same distance between. One example of that is you're looking at a running race, and the person who comes first versus the person who comes second, the person who comes third. If we just see first, second, and third, we don't know how close that race was. Was the person who came first a mile ahead, or was it very close? You would have to go by the timing, yeah. So the order, first, second, third, gives us some information. If we turn it into numerical data with the actual time, then we get more detail. So that's the difference between numerical and ordinal. So listing first, second, third place versus the time that they took. Likert scale is ordinal, but we often put numbers to it, as you can see here, 1, 2, 3, 4, 5, which means we treat it as if it was numerical data. And so we might get an average score of 3.3, which would be between neither, not applicable, and agree. It doesn't really make sense to think about it in terms of that, somewhere on between neither and agree, but or disagree point neither doesn't make sense. But in practice, we can get some meaning out of it. So if this is 3.3, this is 4.5, and this is 4.9, then we know we're doing better on this one and worse on this one. Does that make sense? So we can get useful information out of it. So the point I want to make is, even though the Likert scale isn't properly numerical, we still treat it as if it were, because we can get useful results. I think I've already explained this, that certain descriptive statistics only make sense for certain types of data. Many analytical techniques assume we've got quantitative data. We can save time later by working out what type of data we have before we start the analysis. We can avoid making mistakes. Okay. So any questions at this stage? Okay, so let's take a 5-minute break now. And when we come back, we'll start looking at some of the types of analysis that we commonly do. Like a few minutes.
I don't say the exact cost, but we just want us to strategize for a low cost operation. So I feel like one strategy, and then like stick with it, and then like to keep on low cost operation. Are you also doing that? Oh no, you mean like keeping it? Yeah. So what I do is I think I keep it, but like, but I could. That makes more sense. That's how to do. So then you get to do. But this is and then I go. What I said was that like. So we doesn't have any knowledge. Then in the long run, if we move the market, then we. You haven't also like spoken about like. Oh, you really need to talk about. That's the thing. But the property is not but how do you like to look at this application? I just I do too much track. And I say be very and I just say that yeah. But I'm stuck at that part and I don't that you could only start with you. But then you also need to consider yes, but so what I the job is definitely getting because it's the storage. So he told us to make a company. So what I did was I didn't make a company. Like a real company. And I just say the location. And I could go back to find the profit. I'm sorry, but I just
Okay, welcome back. So before the break, I introduced you to types of data. Now we're going to have a look at what we can do with that data. And that means measures of central tendency. Now, measures of central tendency, they summarize the data for us by calculating a typical value. The mode is the most frequently occurring value. So if we're selling goods online and we want to know what's the most common order that comes in, well, we might find the most common order is $19.95. That would be the mode sale. The median is the middle value. We might find that 50% of customers order $10 or less worth of stock from us. So 50% of orders are for $10 or less, 50% are for $10 or more. That's the median observation. It's closely related to things like quartiles, where we split the data up into quarters, and we could say, you know, the top 25% of our orders are worth more than $30. Or deciles, which are 10 or percentiles or so on. The Pareto principle, which comes up quite often in logistics and supply chain management, talks about the 80%, 20% rule. Well, and that is talking about deciles or percentiles. The other one, which is very commonly used, is the mean or the average. The average is simply the sum of the observations divided by the number of observations. So if we made a total of $1 million worth of sales last year, and we had 100,000 sales, there are actual 100,000 transactions, then our average sale was $10. Here's some examples. We want to make sure that our refrigerated trucks are safe. They're only safe if they're within a certain temperature. The lettuce that we carry in our trucks, well, if it's too cold, it's going to freeze and get damaged. No one wants to buy a frozen lettuce. If it's too hot, then the lettuce is going to start rotting, and no one wants to buy a rotted lettuce. So we need to make sure that the temperature in our trucks stays at a reasonable level. So we stick a thermometer in each of the trucks, and at 9 o'clock on Monday morning, I come to my control deck and I click on the temperature button, and the Wi-Fi sensors bring the data in, and through whatever tech key kind of thing happens to get me the data, and I can see what the temperatures are in my trucks. You can see, and what I get shown is this diagram here, this chart. This is the temperature along the x-axis and the count along the y-axis. So 5 of my trucks are at 4 degrees, and 1 of my trucks is at 6 degrees. What's the modal temperature? Four degrees? Yep, 4 degrees. Why is it 4 degrees? Yeah, it's 4 degrees because it occurs most often. There's 5 trucks which have a temperature of 4 degrees. That's our mode. So we can look then at the median as well. What's the median temperature? Remember, the median is the middle temperature. Why do you say that? No, that's the mean. You're asking for the median now, which is the middle value. Four, yeah, the 4 is the median value. It's the middle value. We don't look at down, let me draw, we don't, make sure you understand how we calculate the median. We don't look down here at the moment. We ignore those numbers to start with. Pretend they don't exist. To calculate the median, we look at these counts up here. And so we add up how many there are. There's 1 there. There's 3 here, which makes for a total of 4 so far. I'm doing the cumulative. 1 truck here. There's 4 trucks which are 3 degrees or colder. There are 5 trucks which are 4 degrees. So 4 plus 5 is 9. 9 trucks there. 10, 11 trucks which are 5 degrees or less. And 12 trucks which are 6 degrees or less. So there's a total of 12 trucks. 1, 4, 9, 11, 12. Okay? So there's a total of 12 trucks. So the middle truck is halfway between 6 and 7. The middle truck is halfway between the 6th truck and the 7th truck. Now, the 5th, 6th, 7th, 8th, and 9th truck are all at 4 degrees. So now we can go down here. So the truck which the 6th truck is here and the 7th truck is here. So the middle truck is here, which means the middle truck is 4 degrees. With a simple set of numbers like this, it might be easier just to type out truck 1 is 2 degrees, truck 2 is that, and then you can easily see what the median is. But you can calculate it from a diagram. The mean is just the sum of the temperatures divided by the number of observations. So we've done the mean, we've done the mode, we've done the median. So you do calculation now. Sorry, I don't actually need to set up that poll. So I had set them up I'd set them up at home, but didn't get around to setting that one up, sorry. So let's then do the calculations ourselves. Okay, so we've got, let me get the Canvas. Just give me a moment to sort this out. Here we go. Okay, so yeah, this is the data for the truck example. I've listed out truck number 1 to 12 and the temperature of each of those trucks. So we already calculated the mode and the median, but we can ask Excel to do it for us. If we type equals mode and then just select the numbers, Excel will calculate the mode for us. This data set is up on Canvas, by the way. If we want to calculate the median, we can just type in equals median. And once again, Excel will calculate it for us. If we want to calculate the average, it's just equals average. Excel doesn't recognize the word mean, but it does recognize average. So the average is the sum of the temperatures divided by the number of observations. So yes, Hugh, you're correct. That is the average temperature. So the mode is the most commonly occurring one, 4 degrees. The median is the middle observation if we sort the data from smallest temperature to biggest temperature, like I've just done here. The median is here because there's the same number of trucks which are colder and the same number of trucks which are warmer. There's 1, 2, 3, 4, 5 trucks which are colder and 5 trucks which are warmer. This is the truck which is in the middle as far as temperature is concerned. And so the mode is 4 and the median is 4. The average temperature is slightly colder at 3.9 degrees. So these are the formulas you can type in Excel. You can also select our old file options, add-ins, manage Excel add-ins, and tick the analysis toolpath. Click OK. If you've got a Mac, it's just tools up the top and then add-ins. And if you select data analysis, you can select descriptive statistics. So data analysis, descriptive statistics, click OK. just tell Excel where to find the data. If you highlight the variable name, you can click labels in first row. Usually say we want it on a new worksheet play. And say that we want the summary statistics. I've just put a screenshot of that in the chat box. So we select summary statistics and you can click OK. If you want the, say, the top 10 and the bottom 10, you click these two here. And that gives us some descriptive statistics. Now, a couple of points at this stage which are very important to remember. The first is this. Excel can calculate a huge number of decimal places. So the average temperature is actually 3.91666666666666 recurring. We don't want to report that as our temperature in the truck. Maybe if you're talking about a spaceship, then they may need that temperature to be measured that precisely. A truck doesn't. 3.9 degrees is plenty enough decimal places. So always make sure you round your answers to a small and reasonable number of decimal places. Small number, reasonable number, consistent. Okay. So give the average as 3.9 degrees. If you told me it was 3.92 rather than 3.9, you're not going to lose marks. But if you tell me it's 3.97, then you'll get a comment. Because unless that difference between 3.916666666667 and 3.9166666668 is significant, then you shouldn't report that many decimal places. Does that make sense? Yeah. It's particularly important in business because you'll just confuse and annoy people. So that's the first thing. The second thing is, here's the descriptive statistics which Excel gives us. They don't format it very well at all. So I always spend a few minutes reformatting things like descriptive statistics. If you're going to put something like this in your report, make sure you format it nicely. Make sure you think about what's relevant in there and what's irrelevant. I once had an exam where the lecturer gave me a set of descriptive statistics and said, tick all the ones which are relevant. If you forgot to tick a relevant one, you lost a point. If you ticked irrelevant information, you lost a point. That's harsh for an exam, and I would never be that harsh with you as students. But in the real world, that's exactly what happens. Okay? You don't want to be presenting meaningless information. You don't want to be ignoring relevant information. You certainly don't want to be presenting information which you don't understand, because I guarantee that's the one that the audience is going to focus on. If I put this in here, I bet you someone's going to ask me, what does kurtosis mean? If I put that in my presentation. And then you'd have to try and explain. And if you can't explain, then you're going to be in a bit of trouble. I mean, I've got a statistics degree and or econometrics. If you asked me to explain kurtosis to you, I would and ah for a moment, and I would say something about the pointiness of it, because it's a complex concept, right? So don't present kurtosis unless you want to have to explain what it means. But by the same token, if your boss is going to want to know about the standard deviation, then make sure you put that in there and that you understand it. So yeah, don't just present raw output. Think about what you're presenting first. Another great, this is actually a good example here. There's 12 trucks that we've got data on. We asked Excel to calculate the descriptive statistics for us, to summarize that data. And Excel gave us 13 summary variables. So Excel turned 12 observations into 13 summaries. It summarized 12 observations 13 different ways. So I think that's actually probably making it less useful, right? You're probably better off looking at the raw numbers than trying to go through all of this. Yeah. So be selective. Very important point there, and probably one of the more important points I'll be sharing with you. Okay, so that's the average. A final point about average versus median. The average is something that everybody intuitively understands in business. Most people understand what an average is. You've used it often enough. So we use that by default as our main descriptive statistic. One challenge with the average, though, is it's really influenced by outliers. So it may not be representative. What do I mean by that? Well, a good example would be house prices. If you look at house prices in Sydney, well, they're all too expensive, but the expensive houses in Sydney are really expensive. Whereas the cheap houses in Sydney are not that cheap. So if we took the average house price in a suburb, where there's 20 apartments and 1 mansion, the average house price will be very much influenced by that 1 mansion. That pulls up the overall average. So you might find the average price is, I don't know, $3 million. But really, there's 10 houses which cost $1 million and 1 house which costs $20 million, and that's pulling up the average. So the average is influenced by outliers. Another good example is sales. The average order on your e-commerce website might be $50, but most people spend only $10. That average is being inflated by the few people who order like $1,000 worth of stock from you. It doesn't mean that it's wrong. It's just not necessarily representative. If you've got a lot of outliers, extreme values, then the median is more representative. You might say, well, 50% of our customers order $20 or less. That might be more representative for your purposes. It really depends on what that purpose is. So outliers are relevant because sometimes our data is very spread out. That's where dispersion comes in. Dispersion tells you how spread out your data is. The more variance there is, the more spread out your data is. The variance, well, that formula is a little bit complicated, but it's actually not too bad. This is the average here. This is the actual observation. So this bit in here is telling you how far away the data are from the average. So that truck might be 6 degrees. The average was 3.9 degrees. So that truck is 2.1 degrees warmer than average. We then square it to get rid of the negatives, add it all up, and divide by the number of observations. So it's basically like taking the average distance away from the mean. Now, on average, that's how far spread out our data is. The fact that we square it, though, means that it's a bit hard to interpret the variance, which is why we calculate the standard deviation instead. That's just the square root of the variance. It's preferred because it has the same units as the original data. So if we're measuring sales of air conditioners, the average might be 5 air conditioners sold per day with a standard deviation of 1. That means standard deviation of 1 air conditioner. And that's why that's useful. So yeah, the measure of dispersion tells you how spread out things are. It's useful because we want to know not only the most common, what's happening, the typical value, but also how much volatility there is. If your sales figures have low volatility, low standard deviation, then it means they're consistent. So the bakery around the corner, they might bake 12 muffins per day, and at the end of every day, they've sold on average 11 muffins with a standard deviation of half a muffin. That means day in, day out, they bake 12 muffins and they sell usually 11, sometimes 10, sometimes 12. Not much volatility there. Another bakery might bake 12, but they might have a standard deviation of 5, which means sometimes they sell a lot, sometimes they sell only a little. They've got much more volatility there. Which would be easier to plan? The bakery which has low standard deviation or the bakery which has a lot of standard deviation? What would be the easier operation to plan? One with low standard deviation, one with high standard deviation? Low? Yeah, we've got a couple of votes for low standard deviation. Absolutely. The one with low volatility is easier to plan. So it takes less effort. And one of the principles in inventory management is to focus on those products which have high volatility, high standard deviation of sales, because those are going to need more work around the planning. So you spend more time thinking about those ones. Although you probably prefer to have products which have low standard deviation because they're easier to plan. If you have products with high standard deviation, then you need to spend more time on those ones, planning them, because it's trickier. More can happen. Yeah. Okay, so that's dispersion. Any questions around that at this stage? Okay. So I've already given you this message. Excel can estimate almost any descriptive statistic for almost any variable. It's up to you to decide, are those actually relevant for your type of data and for your problem? Excel is not going to recognize that you've got categorical data and only give you ones which make sense for categorical data. So it could calculate an average of blue point red for your pens, for instance, because it doesn't understand that you've got categorical data. Okay. So now I'm going to spend a couple of minutes talking about effective presentation, and then we'll have our 10-minute break. So we analyze data because we want people to use that information. So people have to understand our analysis to be able to use it. What that means is we want our analysis to tell a story. We want to communicate complex ideas with clarity, meaning it's easy to understand, precision, meaning we're telling the accurate story, and efficiently, meaning we're not taking up too much of our audience's time. We want to provide a lot of ideas efficiently, and we need to make sure we're telling the truth about the data. How do we do that? Well, there's a lot of tools at our disposal. Some of the most common ones are to put it into words. You can say the average temperature of our truck is 3.9 degrees. That's a little bit on the warm side, but it's perfectly safe. That communicates what's happening. You might say, well, the standard deviation is 2 degrees. That means that some of our trucks are a little bit too hot and some are a little bit too cold. But there's nothing systematically wrong because the average is fine. That might be a little bit too much detail for your boss. What you might say is, well, everything's fine on average, but a few of our trucks are getting too hot and a few are getting too cold, so we need to tighten up on our maintenance. That's presenting the ideas without any numbers whatsoever, but it's based on quantitative analysis. You might present that information in a chart, like the chart we saw here. Because humans find it much easier to interpret a chart than the raw numbers. So a chart is much easier to interpret than these raw figures here, even if I put them in order. A table is another useful way to present information. You're organizing the numbers in to a grid, makes it easier to follow. you need to think about the circumstances and what's going to work for that audience. You need to communicate complex ideas clearly, precisely, and efficiently. Charts are one of the most common and useful ways of doing that. But you have to be a bit careful. You want to avoid chart junk. You want to allow people to properly compare the data. And I'll show you what that means in these couple of slides. So here is a info box. I think these are still quite popular. There were a few years there where they were absolutely everywhere. And you still see a lot of this on internet sites, social media, and that sort of thing. This is information on average weekly earnings in Australia in the transport, postal, and warehousing industries. So everybody from operational staff through to managers. And you can see how it's grown over time. What do you think about this? Does it make sense? Why the icons? Good question. Well, that's a truck, and trucks are part of transport. Supply chains, the chain, boxes. Well, I wanted to show you, say, boxes, supply chains. It's a global industry, but we're talking about Australia, so it's koalas. Yeah. Does that, do those icons help you? No. I mean, if I tell you transport, postal, and warehousing industries in Australia, you know we're talking about Australia. And you can probably imagine Australia has koalas. And we know that boxes are involved in supply chains and trucks. So that's not actually helping things. So we can put a, yeah, those icons aren't actually helping anything. I could have gone further and made those icons blink, but I decided against that. The previous example I had included blinking icons. Now we've got the dates there and a dollar sign because we're talking about money. So I put a dollar sign in, and we've got the actual figures. And one thing which I spent a little bit of time doing is the font size is proportional to the numbers. So the font size gets bigger as the wages get bigger. Does that help to indicate what's going on? I got one vote for not really. What do you think online? Does having different font sizes help? I've actually got a couple vote for yes. Yeah, fair enough. Sometimes it can, and one person says they like it. So it can, if that helps you, then great. Aisha's, I think, made the proper point there that yes, it can help in some circumstances, but it's probably too much effort to communicate something simple. So yeah, think about how much effort you're going to put into what you're presenting. Another way of presenting is like this. Same information in a chart. Is that better? I know I'm leading you by putting a X and a cross there and a tick. But does that help? This one? Yep, you could fix it. Sure. So the one on the left is better than text, but it has chart junk on it. Okay, actually have one vote for this one was easier to understand, the text. Yeah. We could spend all night analyzing this. Each one has some advantages and disadvantages. On the left, I can see that it was May 1995 that the data refers to. You know, the precise date is shown there. The precise numbers are shown there. So that could be useful in some circumstances. I kind of like on the right because you can see that wages increased quite quickly from 2010 to 2015, but growth was slower until 2020, for instance. That's easier to see on a chart than when you look at the raw numbers, for instance. Yeah, it becomes helpful to visualize the trend with this chart. Is there anything wrong with that chart on the right? Anything left out? Anything which isn't helping you to understand what wages did? Yep, an axis title. A trend line. A trend line might help. Yeah. Yep, so this is weekly. What about annual? Would it help if we had more fine-grained data? So annual changes rather than every 5 years? Yep, Wahang asks a great question. What about tax? How much tax was taken out? This. What can you actually buy with that money? Inflation, yeah. So $1,000 in 1995 could buy you more than $1,000 today. What does this look like as a percentage of profits in the industry? So are the workers getting more of the profits or are they getting less of the profits? All of that might be relevant depending on what story you're wanting to tell and what it is that you're wanting to learn about. The difficulty is when you present people information in one form, you're stopping them from being able to see the other stories which might happen, which might also be there. So that's one of the things you've got to think carefully about how you're going to present your data. And I know quite a few people who, before they even start writing their reports, whether it's a assignment or paper or what have you, they'll get their charts and tables properly done and then write the story around those. Yeah. Here's another great one.
Is that a good practice? Like
to
do the charts first and write the story around those?
Well, it really depends on what works for you. I think looking at the charts and the analysis and thinking about the story, I sort of do it iteratively. So I think about the story, look at the charts, think about what they tell me about the story before I start writing. It's up to you. Just want to emphasize that this should be looked at early on in the piece rather than as an afterthought. Yeah. Here's another one. What do you think about this? So we're looking here at the number of high distinction marks received by students. In 300 students receive, 200 of our first year students receive high distinctions. 200 students receive a high distinction in their second year. 225 students in their third year received a high distinction. And 250 students in their fourth year received a high distinction. What story does that tell you? I'll tell you the story it tells me. First year students come in and they work hard. Then they get lazy in their second year and they slack off. Then in their third year, some students are starting to think about the future. Then in their fourth year, they're thinking, gosh, I better do well, get my grade point average up so I can get a good job when I graduate. That's what this tells me. By semester, or if you broke it down by semester, then maybe you could see that even more clearly. Yeah.
Could you also say that it got tougher?
Yeah, it could. We make it easy in first year, so we get you hooked, and then in second year we make it tougher. That's what a student might say, or the teachers. They put the good teachers in first year to wow the students, and then in second year they put the lousy teachers in. Then the good ones can say they want the fourth year students. So the teachers are bad. Or maybe the story is a little bit different. 22% of students receive a high distinction in their first year. 22% of students receive a high distinction in the second year. 22% of students receive a high distinction in every year. And what we're actually seeing there is that there's more students enrolled in first year and fewer students in second year. What this is a relative basis for comparison. If you're not comparing like with like, you're not getting the story. So on the left, what the story is actually there's more first year students than fourth year students at the moment. And so unless you're doing a proper analysis, you'll miss the story. Here's another example. What do you think about this chart? Size? Quarterly sales. So just the number sold. Anything that you might do differently to this chart? Yeah, adjust the axis. Adjust the vertical axis. There's too much empty space there. This is better presentation. Yep, it's the same numbers, but it's harder to see the differences because there's too much empty space on the chart. The only reason you'd show this is if, say, your sales target is 60 and you're showing how far away you are from that, for instance, or you're comparing different stores. This one makes it easier to see the difference. What about this one? It's easy to see the difference there, isn't it? Why connect the dots?
So you can say over the quarters what the trend is.
Exactly, that's why they're connected, to show that how things are progressing. You could do it that way, yes. This is a specific story if you wanted to tell with it, that's why it's like this. The story here, well, if this was the media, we would say with big ticker headlines on the TV, a massive page on the internet, quarterly sales are up from 18 to 22. Look at that massive jump in quarterly sales there, how big it is on the screen. If this was a clickbait website, it would be 10 things you didn't know about quarterly sales. Now, and the same story again at quarter 3. Wow, you won't believe how high quarterly sales are. And then in quarter 4, the story would be quarterly sales disaster, sales plummet, sack the CEO. All of that because you're focusing in too much on the little changes. Where really, if you looked at the full picture, nothing actually much has happened to quarterly sales. They're up a little bit and then they came back down a little bit. Same figures, different story. This shows the 0 point so you can actually properly compare the numbers. The one on the left is probably going to excite people too much. If you do want to focus a bit on the changes, but you want to show people that that's what you're doing, then you can format your chart like this. See how I put a little 2 lines there to show that we've gone from 0 to 17, that there's a break in the chart? That communicates to people that you're focusing on the changes, but you're being honest that you're not showing the full picture. Now, that's actually impossible to do that in Excel. So what I do in Excel is I cheat. I actually create the chart, so that's actually number 16 there. And then I put a little text box over with the 0 in and draw those 2 lines on the chart. So you actually have to sort of trick Excel to do that. It doesn't do that automatically. Right. Any questions about this? Make sense? Yeah. So where you can go with this? Well, there's a lot of interest in dashboards, data dashboards, in dealing with big data, with summarizing data, communicating with data. And as you go through, some of the electives on offer will go into that in more detail. I think it is very exciting, and it's got a lot of potential for helping logistics and supply chain management, A, deal with the huge flows of information coming in, and B, make better decisions. But all of those are only tools to help draw out summaries or to help inform stories. When you're dealing with that massive flow of data, you need to summarize it to be able to start telling stories, to start making better decisions. And that comes from thinking about how to present the information, how you want to receive the information, how you want to communicate it on to others. We're rapidly getting to the stage where no person's going to be able to understand every single piece of data that's generated, even in a small warehouse. So it has to be summarized for you. It's going to be useful to you only if you think about how you want that data to be summarized. So it's going to give you a proper basis for decision making, proper basis for making recommendations. Before you can get into that wonderful world of dashboarding and so on, big data, yeah, I think you need to understand the basics and those storytelling. So we're going to have a 10-minute break now. And when we come back, I'm going to put you into teams and you're going to work on analyzing some data, telling each other stories about the data, and making some decisions and recommendations based on that data. So let's take a 10-minute break. We'll come back here at 10 past and we'll have a look at that.
But the thing is, like, I'm not really sure how the pricing works because, like, if you see the profit of scale, it's only 21,000 per day, and you can ship for 2 weeks. How am I going to put that on? I see that, like, obviously, if I do 1,000, I'm pretty sure I just have to cross that off, and then I just do like, you know, then like, I'm buying it like 4,880 rupees. I need to buy one. Like the value is just like million. It's not like a lot of them. I just got all the yeah. And then just collected the price, but I'm still like my yeah. I think I didn't know. Yeah, there's something, but I think there's no. But like what can I do? It's not the price that doesn't make sense anymore. One cost. Then maybe you could make a better because prospects is even better. I don't really get it. Yeah. So what is the one doing that? What are you changing the future or like whatever you go? It's just not part of what you see the question. I think I want to be back to trying to do what are the future because it's actually sometimes for smaller companies. It is actually cheaper to do and it's actually better. Like nowadays, like the technology is fine. So we want people Like that's the thing, like there's just too much, and if I'm going to mention how much, that's all I just put off the communication.
You don't know before that.
No, I have no idea. It's like what about, but if we want to be more realistic, be more like how people solution, like I just say like we have to do more research and all that, like some like optimization game. Yeah, because like it's actually different. Like now, and it makes a lot of difference. I just it's crazy. Actually, it doesn't reply like even the report that
So you're done. I'm going to finish. We want to know how to do it. When I this is my bill.
Oh, my dear. Okay. I need to remember about that. But
This one is by this one. Even the ranges, so what do you do? So this makes like so much. Just add what every you can get done. Because the 600 word, I'm like 25. Oh, and I was just like, I'm not going to write 25. So much time, and the thing is, every link is unique, right? So to find like the publication, find this, and then you go type it down, and it's just like, so that's why I was doing this thing. But they say that we don't take it. I'm just having it open as last time. No, that's when it's valid. Also, we don't have to make that. I don't know. Yeah. Yeah, because Australia has quite stuff like it's not the case for
Okay, welcome back. So before the break, I introduced some of the types of data analysis. And I spoke about building charts and using information to tell stories to help make better decisions. This activity, as I said, is going to get you to do that. So here's a scenario. In June, a university club is going to go for a trip abroad. They've hired your team to help them select which airline to choose to fly. Last year, they had a miserable time because their connecting flight was late. So they missed their flight. They had to sleep in the airport. They don't want to do that again. So they want to really carefully pick the right airline. You know, there's a lot of pressure on your team to pick the right airline so that, you know, if everybody's sleeping in the airport again, they're going to be grumpy with you. I don't want to make you anxious, but yeah, that's the situation. So very quickly, what would you look for in an airline if you were booking this trip? If the last time you had to sleep in the airport, what are you going to look for now? Price? Yeah. What else are you going to look for? Yeah. Delay insurance? Cancellation insurance? Transit time? So that's the more transit time you've got, the safer you are. But you obviously don't want too much transit time. How likely they are to actually get you on time. How many stops? Yep. Baggage weight, what the weather's like, yeah. Although remember, this is a couple of months in advance, so you may not be able to work out what the weather's going to be like for the flights just yet. So what they've done is I've identified 5 airlines with economical fares. So that takes care of the price factor. All 5 airlines are roughly similar prices. Most of the flights go through Mexico City. They're hoping to find an airline which has the lowest risk of departing late. So they're less likely to arrive late and they don't want to miss their connecting flights again. So they figure if they arrive on, or if they leave on time, they're more likely to arrive at the transit point on time, more likely to make the connecting flight. What I want you to do is spend a minute on your own, looking at the data. Think about which airline do you recommend initially, and then vote in the Zoom poll. So just spend a minute looking at the data. I'm about to share the link to the data with you. It's on Canvas. So if you go to Canvas for this week, you'll find activity C2. Yep, so have a look at that data and then vote in the Zoom poll, which I'm about to open. Well, so spend a minute having a look at the data, which is, say, is available on Canvas or via the link I've just put in the chat box. Have a look at the data. Think about which airline you prefer. And in a minute's time, I'll open up the Zoom poll and you can vote. Richmond. Yep, so spend a minute having a look at the data, thinking about which airline you want to recommend. And in a minute, I'll open up a Zoom poll and you can vote. So this data here shows you they're on how many minutes late they were departing over the last 30 days. So this is the minutes delay or minutes late departing over the last 30 days. So that airline was 5 minutes late on that first day. That was no minutes late on the first day. Does that data make sense? Okay, so I'm going to open the poll now. So now you've had a chance to have a look on your own at the date numbers. Vote for which airline you prefer. So, well, just click on, if you're in, well, yeah, if it makes a difference, we'll add one number. It's not a, yeah, it's not a big deal because you're going to go into your team and then discuss. As long as you've got a record, that's all that matters. Yeah. Yeah. I don't want to ruin the exercise, but yeah, don't. Yeah. You're welcome to go in or not. Yep, so vote on which airline you prefer based on your quick analysis. A couple more people need to vote, and we'll be able to go through the answers. Okay, so last chance to vote. Okay. So here's what you chose. 36% of you said Sky Voyage. And then we had some votes for Central American and South America. And not many people chose Mexico Express or Southeast Airline. Don't worry too much about the percentages, because what I'm going to do now is put you into teams. And I'm going to get you to continue analyzing the data now as a team. And as a team, I want you to come up with what you think is the best option for the team. Okay? So pick one as a team. As you're doing that, I want you to think about what it is that's helping you make the decision. Think about how you're making the decision. Think about why you're making that decision. And you can share your reasoning on the Padlet. So what we'll do is we'll vote in a poll. I'll open a new poll when we come back, and then you'll put your vote in then. While you're making the discussion, go on to the Padlet, into your assigned team, and put your reason as a team. So if you're team one, here's what you'll be doing. You'll go through the data as a team, do whatever analysis you want to do with the data, talk about to each other, convince each other about what you think, about what's the best option. Once your team has decided, put your logic down on the Padlet, and when we come back, you'll vote yourself. While you're making that, think about what sources of evidence you're using and how that evidence is being used as part of the discussion. Does that make sense? Make sense? Okay, so I'm going to open up the breakout rooms now. And you guys work together. On that, the breakout room number that you're assigned to, well, that's going to be your team number. Okay. Off you go. Okay, you guys can be team number 8 if you do that in this group. Yep, so go into your breakout room and have your discussion. Good luck.
I think one iteration. That one is yeah, that's but first of all, how do you analyze then one?
Okay, so it's I'm just giving people another minute or two to put their thinking up on Padlet, and then we'll come back. I'm bringing everybody back. Welcome back if you're coming back. If your team hasn't, please put your findings in the Padlet for this activity. The Padlet link is in the chat box. Okay. So welcome back, everybody. I'm going to open the poll now for you to vote on who you think, who your team decided should be your preferred airline. So please vote in that poll according to what your team decided. Also, I think a couple of teams haven't put their thinking down in the Padlet. So team 1, 2, and 5, if you could just enter that information in the Padlet, that would be great. So everybody can see your thinking. Yeah, so please vote on the one that your team chose and put your logic down. If you haven't voted, please do the vote. Okay. Another 10 seconds. Vote. Okay. I'll end the poll now. Which one did you choose? Sky. Okay, doesn't. That's fine. Yep. Okay, so sharing the results. There actually were a couple more votes for Sky, which didn't get included. But this is very interesting results, I think, here. The consensus is now around Sudamerica. If we go back to the first poll, Sudamerica was equal second with Central American Airlines. Now that you've had that time for discussion, Sudamerica has become the most popular. So, what drove your decision making? Why did Sudamerica suddenly become #1 and everybody rejected Central American and Mexico Express? So, what's your thinking? Team 1, what was your logic?
So we were actually looking at mean mode, median, and standard deviation, because mean was pretty much same for all the airlines. And so looking at the mode, so we preferred all the airlines which were 0. So so that eliminates, we actually applied elimination strategy. So we eliminated Mexico Express. And then we had 4 more to go, and then we looked at median. So the lower median was Sky Voyage, and then Sudamerica International. So and we chose Sudamerica International because the standard deviation between those two is lesser at Sudamerica, which is 20.4. as compared to that of Sky Voyage. And plus, we also calculated the percentage. So Sudamerica was 57% on time, then Sky Voyage. So Sky Voyage was 50% on time. So that's why we chose Sudamerica International.
Okay, thank you. So team 3, you chose differently. You chose Sky Voyage. you want to share your explanation as to why you chose Sky Voyage?
Hello, Jeffrey. Yeah. Yeah, definitely compared to other 4 lines, what we are mainly chosen, already in the past experience of the student, there was a delay. They have missed the flight in the transit. To considering that, the more than 50% on an average in a month, what your data showing, it was in 0 delay. The 0, which means they are on time. Even though if you are taking compared to others, there is only 1 day, which means 123 in a month, it will be negligible. Apart, all are is only for the more than 10 minutes to 10 to 20, 10 to 30. It can be quite normal. Why? Because there are other issues. It will be added in the airport, but we are not sure. But that can be acceptable. Passenger may not raise the issue, but the point is it will be the very accurate departure compared to others, and also there was no delay more than 5 days in a month. That will be very crucial point which we have considered compared to other airlines.
Okay, thank you for that. Yeah. So a couple of different approaches there. And the first team we heard from used an elimination approach. They eliminated the ones they thought were horrible and then picked from the remaining ones. Did you do that? Yeah, team 8 did the same thing. When I look at this data, this is my analysis. So I've just highlighted here using conditional formatting, the days in which the delay is less than 5 minutes. My view is that if it's less than 5 minutes delay, then you can consider it's pretty much on time. I don't really worry if it's 5 minutes late. That's in leaving, because it's probably going to get there roughly on time anyway. And even if it's 5 minutes late, if you've given yourself an hour and a half for transit, 5 minutes should be neither here nor there. So that's why I highlighted the ones for less than 5 minutes. It's actually, sorry, no, it hasn't, not quite less than 5 minutes, because there's one which is 4 minutes there. Sorry, just give me a second to check the conditional formatting. If it's less than 4 minutes, sorry. If it's less than 4 minutes, I highlighted that. Why 4 minutes rather than 5 minutes? Well, that would be up to you to pick what you think is a reasonable delay. And I think that comes to what you were saying there, Bala, previously about how you chose Sky Voyage because most of the time its delay is reasonable. Not too much delay.
Yeah.
Yeah, so that's similar to your logic. So if we go down and have a look, so if we have a look here, you can see Central America and Mexico. They don't get you on, they're not very often on time. So I think that's why most people eliminated those ones quite quickly. Southeast Airlines sort of in the middle. So you might want to leave that in or might leave it out. You know, not necessarily right or wrong. Sudamerica and Sky Voyage, they're definitely on time exactly most often. And they're not that often significantly late. So those are both reasonable options from that, as far as I'm concerned. Then we can look at the descriptive statistics. The average delay, and this is where the trick comes in this question. Notice the average delay is actually identical across the board. So the average isn't actually going to help us make a decision here. I heard people talk about the median for Sudamerica. and Sky Voyage being low delay. And in fact, Sud-America is on time 50% of the time. The mode delay, Mexico is on average, well, sorry, the most commonly occurring thing for Mexico Express is it's 5 minutes late. So it's got a mode that's not equal to 0. And if you have a look at there, yeah, it's often late by 5 to 10 minutes. To be honest, that suggests to me that their timetable needs to be fixed. If they just put their timetable so it gave them an extra 5 minutes, then they would be on time, wouldn't they, far more often. Maybe there's a marketing reason why they want to look like they're quicker than they actually are. I don't know. Maybe they just need to get somebody new to do their timetables for them. We can also see the minimum doesn't tell us anything. The maximum is interesting. Sky Voyage and Mexico Express both had cases where they were very late. I heard Bala ignored that or took that out of consideration. That's what comes down to personal preference, doesn't it? If you're thinking, well, if it's 1 hour late, I've missed the connection. So if they're 2 hours late, who cares? It might as well be 10 hours late. That's one way of looking at it. An alternative approach might be to think, well, 2 hours is a really bad delay. I'm going to avoid that. And I don't think there's a right answer to that. It's up to the individual there. Does that make sense? Yeah. So yeah, you can think about how bad the worst case is, or you may ignore the worst case. I've also calculated the 3 worst delays. So the 3 worst delays for Mexico Express were only 12 minutes late. Half an hour is the 3 worst for Southeast, 25 minutes for Central, Sky Voyage and Sud-America had some big delays. That may be relevant for some people. I don't think it came up in the Padlet, but for those ones when they're late, they can be quite late. Whereas Mexico Express tends to be consistently a little bit late. Yeah. So this was very carefully constructed data, not by me, by I think one of the American universities, to make sure that there was no easy answer to this, that there are lots of different ways of thinking about the data, analyzing the data to come up with the story. What this really I wanted you to take away is that means there's no right or wrong answer to most kinds of data analysis. Sure, you can do the analysis correctly or you can do the analysis incorrectly. But the real art is in choosing what analysis to do and then interpreting the result that you get. And that really, really depends on the individual as to which way you're going to end up, what story you're going to tell. And there's not necessarily a right or wrong way to do that. There are good reasons to pick any of these 5 airlines and good reasons to eliminate any of those 5 airlines as well. Which one that you choose, well, that depends on what you prioritize, what you think is most relevant and so on. That could be a little bit scary. Well, we're talking about numbers, surely there must be a right answer, but we're not, because we're talking about how you interpret that. So yeah, I'll leave you with that thought. It's now 9 o'clock, so we'll finish up. Thank you for staying there. As I mentioned, next week we're going to have a practice session before the computer exam. So see you next week.
Thank you.
No worries. Bye for now.
Thank you.
Thank you.
Hello, teacher.
Hi.
For the midterm exam, do we need to download the Invigilator software?
Yes, there will be some software that you'll need. Have you been given access to the exam site yet? No, you should get access to the exam site shortly if you haven't already. That will be a Canvas site. You won't be able to see the actual exam, but you'll see the site, and that will have instructions on what to do. I'll make a note to send out some, to find out what the information is that you need to do this week in preparation, because you'll need to set yourself up. Yeah, so I'll send that out tomorrow.
Okay, thank you. When do we have this exam?
It's 2 weeks in the regular class time. So I think that's the 12th.
Okay, thank you.
No worries.
That'll be just visible on our dashboard on Canvas, will it, Jeffrey?
The
exam site will be visible on our dashboard.
It will look like just another Canvas site. So
yeah. Okay.
Yeah. So if you're on your dashboard,
yeah.
I'll show you my.
Just a tile on there.
Yeah, it will be a tile which will say something like, well, I can tell you exactly what it's going to say.
Okay.
I already have that one. In semester test for ITLS5050.
Cool.
So yeah, it's unpublished at the moment.
Yeah.
The school is going to publish it at some stage, and then you'll have access to it.
Awesome.
Or you'll be able to see, first of all, the instructions for what you need to do prior to the exam.
Okay. Thank you.
And then on the day, obviously, you'll be able to click on it and have the exam.
Great. Thanks.
Take care.
Thank you.
Bye.
See you next week.
See you next week.
Thank you, Jeffrey. Have a nice day. Good night.
Yeah, thanks, Jeffrey. See you. Goodbye.
Hello, Jeffrey. Bala here. Hello, Jeffrey.
Bye for now.
Yeah. Bye. Good night. Good night. Have a nice day.